Iron chloride, also called ferric chloride, is an industrial-scale commodity chemical compound, with the formula FeCl3 and with iron in the +3 oxidation state. The color of iron chloride crystals depends on the viewing angle. By reflected light the crystals appear dark green, but by transmitted light they appear purple-red. Anhydrous iron chloride is deliquescent, forming hydrated hydrogen chloride mists in moist air. It is rarely observed in its natural form, mineral mollicite, known mainly from some fumaroles. When dissolved in water, iron chloride undergoes hydrolysis and gives off heat in an exothermic reaction. The resulting brown, acidic, and corrosive solution is used as a flocculant in sewage treatment and drinking water production, and as an etchant for copper-based metals in printed circuit boards. Anhydrous iron chloride is a fairly strong Lewis acid, and it is used as a catalyst in organic synthesis. Nomenclature. The descriptor hydrated or anhydrous is used when referring to iron chloride, to distinguish between the two common forms. The hexahydrate is usually given as the simplified empirical formula FeCl36H2O. It may also be given as trans Fe4Cl2, Cl2H2O, and the systematic name tetra-aquadichloroiron chloride dihydrate, which more clearly represents its structure and properties. Anhydrous iron chloride adopts the BiI3 structure, which features octahedral face centers interconnected by two coordinate chloride ligands. Iron chloride hexahydrate consists of trans Fe4Cl2 plus cationic complexes and chloride anions, with the remaining two H2O molecules embedded within the monoclinic crystal structure. Iron chloride has a relatively low melting point and boils at around 315 degrees Celsius. The vapor consists of the dimer Fe2Cl6, which increasingly dissociates into the monomeric FeCl3 at higher temperature, in competition with its reversible decomposition to give iron chloride and chlorine gas. Preparation. Anhydrous iron chloride may be prepared by union of the elements 2Fe plus 3Cl2. 2FeCl3 solutions of iron chloride are produced industrially both from iron and from ore, in a closed-loop process. Dissolving iron ore in hydrochloric acid Fe3O4 plus 8 hydrogen chloride FeCl2 plus 2FeCl3 plus 4H2O. Oxidation of iron chloride with chlorine 2FeCl2 plus Cl2 2FeCl3. Oxidation of iron chloride with oxygen 4FeCl2 plus O2 plus 4 hydrogen chloride 4FeCl3 plus 2H2O. Reacting iron with hydrochloric acid, then with hydrogen peroxide. The hydrogen peroxide is the oxidant in turning ferrous chloride into ferric chloride. Like many other hydrated metal chlorides, hydrated iron chloride can be converted to the anhydrous salt by refluxing with thionyl chloride. Conversion of the hydrate to anhydrous iron chloride is not accomplished by heating, as hydrogen chloride and iron oxychlorides are produced. Reactions. Iron chloride undergoes hydrolysis to give an acidic solution. When heated with iron oxide at 350 degrees Celsius, iron chloride gives iron oxychloride, a layered solid and intercalation host. FeCl3 plus Fe2O33 It is a moderately strong Lewis acid, forming adducts with Lewis bases such as triphenyl phosphine oxide, e.g., FeCl32 where pH equals phenol. It also reacts with other chloride salts to give the yellow tetrahedral FeCl4- ion. Salts of FeCl4- in hydrochloric acid can be extracted into diethyl ether. Alkali metal alkoxides react to give the metal alkoxide complexes of varying complexity. The compounds can be dimeric or trimeric. FeCl3 plus 3, C2H5O minus Na plus Fe3 plus 3 NaCl oxalates react rapidly with aqueous iron chloride to give Fe3, 3 minus. Other carboxylate salts form complexes, e.g., citrate and tartrate. Oxidation. Iron chloride is a mild oxidizing agent. For example, it is capable of oxidizing copper chloride to copper chloride, FeCl3 plus CuCl, FeCl2 plus CuCl2. It also reacts with iron to form iron chloride. 2-FeCl3 plus Fe3. FeCl2 reducing agents such as hydrazine convert iron chloride to complexes of iron. Uses. Industrial. In industrial application, iron chloride is used in sewage treatment and drinking water production. In this application, FeCl3 in slightly basic water reacts with the hydroxide ion to form a FeOC of iron hydroxide, or more precisely formulated as FeO-, that can remove suspended materials. Fe6 3 plus 4Ho-, Fe24 plus 4H2O, FeO2 plus 6H2O. It is also used as a leaching agent in chloride hydrometallurgy, for example in the production of C from Fe. Another important application of iron chloride is etching copper in two-step redox reaction to copper chloride and then to copper chloride in the production of printed circuit boards. FeCl3 plus Cu, FeCl2 plus CuCl, FeCl3 plus CuCl, FeCl2 plus CuCl2. Iron chloride is used as catalyst for the reaction of ethylene with chlorine, forming ethylene dichloride, an important commodity chemical, which is mainly used for the industrial production of vinyl chloride, the monomer for making PVC. H2C equals CH2 plus Cl2Cl CH2CH2Cl. Laboratory use. In the laboratory, iron chloride is commonly employed as a Lewis acid for catalyzing reactions such as chlorination of aromatic compounds and Friedel-Crafts reaction of aromatics. It is less powerful than aluminium chloride, but in some cases this mildness leads to higher yields, for example in the alkylation of benzene. The ferric chloride test is a traditional colorimetric test for phenols, which uses a 1% iron chloride solution that has been neutralized with sodium hydroxide until a slight precipitate of FeO is formed. The mixture is filtered before use. The organic substance is dissolved in water, methanol or ethanol. Then the neutralized iron chloride solution is added. A transient or permanent coloration indicates the presence of a phenol or ENOL. This reaction is exploited in the Trinder spot test, which is used to indicate the presence of salicylates, particularly salicylic acid, which contains a phenolic O group. This test can be used to detect the presence of gamma-hydroxybutyric acid and gamma-butyrolactone, which cause it to turn red-brown. Other uses. Used in anhydrous form as a drying reagent in certain reactions. Used to detect the presence of phenol compounds in organic synthesis, e.g., examining purity of synthesized aspirin. Used in water and wastewater treatment to precipitate phosphate as iron phosphate. Used by American coin collectors to identify the dates of buffalo nickels that are so badly worn that the date is no longer visible. Used by bladesmiths and artisans in pattern welding to etch the metal, giving it a contrasting effect, to view metal layering or imperfections. Used to etch the Widmanstatin pattern in iron meteorites. Necessary for the etching of photogravure plates for printing photographic and fine art images in intaglio and for etching rotogravure cylinders used in the printing industry. Used to make printed circuit boards. Used in veterinary practice to treat overcropping of an animal's claws, particularly when the overcropping results in bleeding. Reacts with cyclopentadienyl magnesium bromide in one preparation of ferrocene, a metal sandwich complex. Sometimes used in a technique of raku-ware firing, the iron coloring a pottery piece shades of pink, brown, and orange. Used to test the pitting and crevice corrosion resistance of stainless steels and other alloys. Used in conjunction with N-acetonitrile to mildly reduce organic azides to primary amines. Used in an animal thrombosis model. Used in energy storage systems. Safety. Iron chloride is toxic, highly corrosive and acidic. The anhydrous material is a powerful dehydrating agent. Although reports of poisoning in humans are rare, ingestion of ferric chloride can result in serious morbidity and mortality. Inappropriate labeling and storage lead to accidental swallowing or misdiagnosis. Early diagnosis is important, especially in seriously poisoned patients.